My name is Dmitra Levashova, and today Dmitra invited me to talk a bit about agents and how actually we deal with them in production. And this is, I think, hot topic in any area. Or everyone talks about AI, LLMs, and related things. I was surprised when recently I heard as parents were chatting in a public transport which agent is better to use. And today, actually, we will talk about this topic. We will cover three domains. Actually, how LLMs are connected to agents, how to deal with multi-agent system, and actually how to control everything we could build there. And let's start as general as possible. And let's be honest, in our imagination, agents is somewhere who come and solve problems. We just put it, and it's reliable person or program that do everything that perfectly follow instructions, that will make the most rational decision. Well, on practice, behavior of agents is much closer to this one. Because agents, as any ML system, just optimize their function. So it's minimize the function, and it generally is stochastic. So if there is a local minimum, so if there are ways around to achieve the same goal, that they would be used. In a most general sense, LLMs are systems that predicts next word. So it's just the most common definition. They just estimate a probability in a sentence to use their to have the next word and take it. Of course, with some randomization, but they usually have a parameter of temperature and they control it. But on practice, majority of people who use LLMs actually don't even care about how they predict. They just use it as a black box. They put text in, they get text out, and they operate with it as some magic box inside. The beauty of this system is that it became so complex that you can even put instructions, and by predicting next word, it will follow those instructions. That's why on the market you can observe a very interesting trend replacing coding algorithms by prompting algorithms, where you describe what you want system to do, and it tries to follow instructions. There are a lot of techniques. How can we prompt it? And on a screen, you can see one of those. So basically, you describe to an agent context, which is domain information, objectives, what you would like it to achieve, perhaps with examples. You describe what role, because it's very funny if you ask to do the same but act as a student or as a professor, you will get completely different results. And of course, expectations. You could describe, you can give exact examples, you can describe patterns, and LLM, depend on how good it was trained, it will follow the instructions or not, because the system is stochastic. To highlight the power of prompting, we can take this example. It's called chain of thoughts, and it is presented as it's pretty powerful technology. What it means that instead of giving immediate answer, instead of predicting next answer, the system starts thinking and breaks the process to steps, like instead of counting immediately, it search for analogies, it tries to decompose it to a simple operations, etc., etc. It started from a publication where authors told that just adding one simple sentence and asking LLM to think step by step, cognitive reasoning of the model would be improved. So basically, chain of thoughts looks like this. You put a lot of prompt with what you want to do, and then ask the model think step by step. Of course, if you put more context, if you put more instructions how it should think, with decomposition, with what entities it should find, that would also improve the quality of thinking. But generally, again, it's just a text which affect outcome of big complex model. And now let's do a one step aside and think a bit why they're useful, why a lot of businesses currently try to implement LLMs. I don't think we have enough people for a survey, but so let me share that main reason. It is in simplicity, because it's looked like a magic. You put instructions how it should work, and it just work well in some ideal in some ideal world. On practice, you can't really put a LLM or agent based on a LLM in a production environment, and practical tests in when LLM manage a shop, offline shop, shows that it's not so successful. It makes a lot of stupid mistakes. So in production environment, most companies try to implement it as a part of a pipeline. So you have a certain trigger, certain action, then you have an agent that reacts on it, and then it performs certain action or give outcome or do whatever with that information. And as most business cycles are built, and look, this agent could take a part of job that people used to do manually, and this was actually where main economical advantage of agents comes. But if we return to our LLMs and let's look on a difference between LLM and agent itself. When we talk about LLM, this is a neural network that built for NLP, and it just predict next token. Agent is an entity, usually an object in a system that works with a certain events, that has LLM as a part of it, that can also use some extra instructions, tools, can use knowledge bases. So basically, when you take LLM and productionize it, you get an agent. So there is nothing complex, just a wrapper around it. And one of the most I would say fundamental things that made LLMs usable in reality was okay, actually a functional call, but we'll talk about it later. Sorry, mixed slides. So let's talk about components of that agent. And first component is a prompt. This actually the same instructions you can put to LLM, but then you split it to two parts. First, you describe a behavior of an agent, some fundamental prompt that you want to ping and call every time anyone send message to LLM. For example, if you have a chatbot that answer questions based on certain documentation, you can put in a system prompt, a tone, effect that it shouldn't use any information outside of document, so it shouldn't use its knowledge. That it should be always polite and try to answer as precise as possible, etc., etc. So actually, you describe how the process would go, which sources to use, and information about tools. And then when final user will come and ask questions, it will add short prompt, and LM would combine it and generate certain response. Second important thing to mention is tools that agent call, and that's possible because current models implement a functional calling. So basically, it's ability of LM to call to run a container with a code to get some third-party tools or get third-party to execute code. And here is two fundamental things. First is skills, and second is MCP service. That's basically skills that you that attach to a certain service. And when we talk about skills, it's additional information or additional that we put to LM so it can do job. As we already discussed, LMs are predicting next word. So by definition, they are bad with math because they work with texts. In most cases, they don't even see numbers and as a one solid entity. They don't have external information, external databases, and of course they need extra clarification when they do a certain type of job, for example, analysis, write a report, or communicate with people. And this is exactly what skills of the agent represent. When you put resources, this is literally an API call, which gets an extra information for agent to operate with. You can put the call to database, you can put it call to some website, you can add files, so any kind of information you can put there. Tools, usually it is a function that could be executed. So it's built as long description, which clarify all aspects of using the function itself. So basically, based on description, LM could decide in which cases a certain tool could be used. Most commonly, tools are used to perform arithmetical operations. And prompt, again, it's just text instructions how to deal in a certain situations. It might consist of a style. It might consist best practices, etc., etc. Skills usually are organized as folders with markdown files, examples of scripts, and API calls. The most widely used it is in cloud code and different systems that Anthropic has. But generally speaking, every company has their own way to implement these skills, and they call it a bit different. There is one more universal thing, because on practice there is pretty often a situation when you have a project and you want to standardize how LLM communicate with it and how LLM work with it. And to do that, there is a MCP protocol, Model Context Protocol, which describes how you can standardize tools, then published as a server, and then any other LM could use it and operate in your environment in a way that actually you want, but not guessing. Usually it is done per project. So you have a project, then you build an MCP server for it with commands related to it. But of course, each agent could use multiple MCP servers. It could, or one MCP server could be connected to several projects. It's pretty flexible format. From the last tendencies in this domain is transforming web pages and websites to MCP servers. So agents could directly buy things without interacting with front-end. But also adjusting a front-end, so to adding text for agents. So they can easily find which element on a website is responsible for a certain action. Okay, let's go next. And this is our knowledge database, which LMs are used. Mostly they're presented as a RAG system. RAG stands for a database that operates with, this is vector database that is a storage of different documents. So how it works? As you know, the core component in any NLP process is how you present text as numbers, as vector. And for our system, you take your documents and you convert to these vectors, basically embeddings. There are a lot of techniques how to do it, but most commonly they are linked to a LLM you use. So you train embeddings together with LLM. And with this transformation, you are getting numerical in numerical space all your documents you would like to have. When you want to get something similar, when you have a request, you also convert it to the same numerical space, and then you search through it and take the most relevant documents. As a distance, commonly used cosine similarity between vectors. Modern system use around vector lengths around 1,500, so pretty complex space, but it works fast, and it doesn't operate with the text itself. It's more to link a right piece of text. Then you take it and load it to LLM to actually to perform certain actions. Okay. That was about tooling. But on practice, it's pretty often when we want to not have one agent but split our systems to steps, or when we want to run it when we have several agents that could attack the same problem but from different angles. Basically, any idea that we apply to ensembles of ML models could be applied also to agents. And there are several architectures how people build it, most commonly. The most common is a chain. So when you have a trigger, which after trigger you have several steps, and then it's marked as done. It's very simple. It's you can code your agents so they will do simple steps and log results. You will have perfect observability for process. You will every time know when it fails, etc., etc. Very simple. Works for the most processes. Just because of simplicity, because most of processes are designed actually to be split in steps. Some processes, for example, when you have a system that should do some research, could require more complex steps. And here you build some kind of Markov chain, and you build a graph on interactions for agents. Again, Each agent perform a simple task and then send a response to another agent. Then process and send it further. Depending on conditions, it decides where it would go. Works pretty well when you need, for example, a brainstorming, or when you need a system with evaluations, and you would like an extra loops and rejection if something can't pass tests. Last interesting thing looks like a group that works on a problem. Again, we have trigger that initiate a workload, and we have one central agent that decide to which another agent currently the request would be sent. So we have one orchestrator, and we have certain agents with their own prompt to do the task. This is why actually it works, because again, prompting is completely changing behavior of a model. And if we remember the main principle of model ensembles, the average of outcome of different models are usually generalized result better than each individual result. But of course, this is a nice rule to follow, but we would like to measure and to know exactly how does it work and where it goes. And on a measurement, it works very, very simple. So we have a success. Usually we measure probability of an agent to give a successful result. Simple as that. We take successful attempts, we divide by total attempts, and we get a probability. Much more interesting goes when we look on what we can measure. First of all, it is outcome, and we have input, we have output. If we are happy with output, we say that it is a success. Second one is action and trajectory metrics. So as our agents could do a multi-step reasoning, they could use a different tools. We could analyze exact actions they do for cost optimization, for resource optimization, to not to call another agents that are not supposed to. So basically, we take all actions they perform, we compare it with some ideal scenario, and we say how good it match. And again, we can count it as a successful correct decision divided by total decisions, but also we can take a percent on each individual funnel. Last but not least is cognitive accuracy, and this is something that is highly related to RAG system and knowledge database. Basically, how often your system hallucinates. So if it hallucinates a lot, and a lot of facts that it returns to you are not from initial data set, then you can't use the system. Basically, you can't trust, because it could fail on any moment. And on practice, there is a commonly need to compare observed probability with some expectations, because when you use it to historical comparison, how evolve your model through after retraining, or how another how another model perform on your data set. Also, how your model evaluate versus human brain. So when you want to build some judge LLMs or things that evaluate another processes. So this coherence kappa could be really useful, and could help you scale the KPI. Another important thing to mention is stability metrics. There are two the most popular. Actually, one represent a probability of outcome of the agent to pass all k tests, to be successful in all k attempts. It's commonly used in production system, or when you build something where you have to rely on results, so you can't retry. And if your system allow retry mechanism, you can use the second one, which tells which represent a probability, so at least one generation out of k would pass your tests. It's commonly used for code gen when you can have tests. It can be used for offline evaluation because you can generate multiple times and test each individual results, etc., etc. But these metrics are good, but there is one fundamental question that is not answered. Who decide what is right and what is wrong? Because we don't want to sit and manually check each response for LLM. And here comes another concept called judge agent. It takes input, it takes output, and it decides to what actually correct, what is not. Then, of course, you have another question: how to train this judge and how to evaluate if it's doing correct things or not. And this where humans have to step in and create things called golden data sets, where we have predefined inputs. We describe ideal path that we think the system should go. We describe ideal output and criteria, and then invest a lot of time so judge could pass all tests, will write manually. Usually this is not real task, and it could take a lot of time actually to make it. So this is really a great technology, and so it's already changing the world around. But yeah, let's be aware that we do need to keep an eye on how it works and and what it does. Thanks a lot for your attention, and this is a moment you can ask questions.
I have a question. Not really technical, but rather.
My apologies. Let me make it a bit louder. Tell something, please.
Yeah. I have a question. Not really that technical, but rather more general. I've recently watched a video that there is a MIT wrote out a research about the AI taking our jobs and all this stuff. It was more about the skills, but not about the jobs itself. So how using these agents, we can increase productivity in certain areas. And previous researchers based on just the US market estimated that around 2% of jobs are at risk. But if we and they call it the iceberg effect, and if we analyze it in terms of skills, in terms of skills, so we are speaking about 10-11% of job. So just curious, what are your thoughts about these agents? How they will be used in the future, different office.
So sorry, yeah, did I got your question right? That you're curious how skills affect agent capabilities and how actually that would what percent of basically market that they would take. Did I got your question right?
Yeah, generally yes, but just curious what are your thoughts because they are becoming more smarter and smarter and they can do more stuff. And generally this is the
Mhm. Okay.
send it in chat.
Yeah, let me try to describe it in this way. First of all, we should understand that term in the beginning, term AI, artificial intelligence, is not correct. It's just a mathematical abstraction that predicts next token. And because the most beautiful thing for it is that it became as complex that it could actually replace a certain standard processes for that usually human do. Uh, in the same time, and for sure, agents will replace part of jobs on the market. And why? Because to run an agent, you pay like several thousand per month. To pay human to do the same job, you pay 3 times more. Why? Because of regulation, because of just salaries are high, etc., etc. So because of cuts, company tend to switch to agents, and skills are really great argument to actually argument when in discussion if we can customize enough behavior of agents uh, actually to do any kind of job. But in the same time, we should remember that this is a stochastic system. So even if you directly say that an agent shouldn't do something, there is a probability it would do that. If you never mention it, uh, and you give this tool, it could be suddenly used. There is a widely known example where agent was this where agent just deleted all files from a computer. It was controlled. That actually, I would say in this way, agents could automate a job and could boost productivity, but much and I don't really expect any type of IT job in future to happen without agents. But their main advantage is in boosting productivity of a person, not replacing completely it. Because of this exactly how to say it, bug, not bug, it's just big property for agents. You can't trust them in everything. There is always a certain moment when everything could go wrong, and sooner or later it would. For people, historically, we invest a lot of time in different organizational structures and organizational processes to actually prevent those from happening. So it's like a postponed decisions. This is making decisions hierarchical, etc., etc. Generally, right now, I see on the market that companies try to apply the same logic for agents, but this is completely different entity. So on this stage, I don't expect that AI would take all intellectual jobs, but it definitely affect the market. Did I answer your question?
Yeah, thank you. Just was curious about your thing.
Okay. And actually, if you would like to start learning about agents and how you can boost your productivity with it, you can take, for example, Notebook LM from Google. It's completely free, and start working with your knowledge and actually not your knowledge, but your sources of knowledge to prepare certain reports or to dive into new topics. That's actually a very good example how it could affect productivity. And this is type of skills that that's needed on the market.
What do you think? Is better ChatGPT Pro, Both Pro, or
No.
the Notebook LLM
Let me
from Google?
show. ChatGPT and other models is just the models. So let me show you. For example,
we're so excited for our very first special guest. He built modern AI. Then
guys, this is interview I do recommend to watch, but perhaps not during this session. So, Notebook LM from Google. So this is a service that allow you to generate, to form your RAC database from a sources. You just click, you can directly add certain websites or documents or whatever, and then you can chat with it. Here you can see what I use to prepare to this presentation. It can even do some slides.
I got it. This is you print your knowledge base like in the where you gather the knowledge and I got it.
Yeah, exactly. So it's just an example how agents, how you can work with agents and to actually to still get benefits from it. So it can prepare a lot, but again, in a science, if you take agents in vacuum, there are too many corner cases, and most ambitious projects we had stuck because of limitation of agents. They still need control. They still need human in a loop. Okay. Okay. Any other questions? Oh, and to be transparent on a screen, you saw a Notebook LM that I used to prepare to this meeting. So, indeed, if you saw familiar topics, they were used here. Slides I had to write myself because LMs are still horrible in writing slides. Okay. Any other topics, questions? Oh, Leslav, I see you shared the picture. I missed it.
Yeah. This is I mean how it was described as an agent replaces certain skills, thus making the fear of occupation demand less people because less people will be able to do the same work using agents by replacing the skills which were other people to do.
Okay, well, that's possible scenarios. Right now, it's really hard to foresee. It's more in an area of expectations.
Yeah, maybe I have a question. No one else's. asking anything.
Dmitry, could you tell it a bit louder? Sorry, something with my volume.
So the question, what LLMs I usually use in production?
In production, we use several types of systems. So our infrastructure is on Copilot, and we are linked to Microsoft. So we use Copilot integrated in Teams to automate routine tasks like meeting summarization or to keep some notes or to work with documentation on SharePoint. We have separate pipelines on a website, and for that we basically we experiment with different models. So majority of modern system allow to use different LLMs and check outcomes of those. So I can't say that we are stuck with something there. And we use Copilot because it provides really great integration capabilities with SharePoint and the rest of Microsoft infrastructure. But for production and for a website, we experiment. There is no preference.
Okay, thank you.
Yeah, Lislav, and are you satisfied with Copilot?
Generally, yes. It covers like most of my needs to my job, but especially it's great that they integrated it in the Outlook, and we have a lot of emails there, and I can now read, summarize, and like go back to, and this is very smart.
Yeah, actually, nice case. And Dmitry, did I answer your question?
Yeah, sure. Thank you.
Yeah, you're welcome. Any other questions? Oh, perhaps then a question from me. Do you anyhow integrate LLMs or agents in educational process? Because I'm curious how it's done. Okay, sorry.
Well,
I'm here to answer questions, not asking.
Well, as for me, I use LLMs a lot in educational process. For preparing for my lectures, I use Notebook LM. I use EMF for presentations. I use just ChatGPT and so on. I don't think that we have integrated any LLMs in, for example, Moodle, but I think it would be done at some point. I've seen some successful integrations becomes very useful. I think not in our system yet.
Okay, thanks a lot for sharing. And is there a chatbot where you can go through basically through lectures to remind yourself what was about?
maybe not something that you can have out of the box. Not something integrated in our systems.
Okay.
I think you
But
can
yeah,
use that notebook LM for that. You have some recordings.
It's common situation where there are more ideas than resources to implement it. It's absolutely cool. Thanks a lot for sharing. Any other questions?
What do you think the nearest improvements of using agents?
Currently, I see that for LLMs for big models, the market goes into two directions. Like Western world with big data centers make them bigger and more complex, and there is a DeepSeek that's heavily invest in computation accuracy. If that would, I think combining of those two could bring significant boost to the domain. But in parallel with LLMs, I see a trend for SLMs. So for small models that are trained and fine-tuned on more niche data that could perform only one type of job. They are cheaper, they are more accurate because they are focused on a certain domain. And honestly, I expect the biggest progress there because I already follow a Google trend where they try to make an SLM run on a local machine together with browser, and basically all trend with transforming websites for web MCPs is built for it. There are announcements for smartphones with inbuilt LLMs there, and Google recently released several networks that specify exclusively on function selection. So they're not good with chatting with people, but they are really good selecting which tool to use in this particular situation. So they can take a certain part of a pipeline and basically replace API layer for some applications, some complex applications. Yeah, so I would say these two trends. So combine computation efficiency with a lot of computational resources could give us first boost. Second is a progress in SLM. I still hope that there will be more researches about information that is stored in inside LLMs, because I think that one of greatest achievements that LLM bring us that they take traditionally unstructured data, which are written in text and human natural language, and they transform it in numerical form matrices on which we can apply strict mathematical logic. I saw only few researchers there, but I hope that more would come later.
Okay, thank you.
You're welcome. Other questions?
Dear Dmitra, would you like please say in Ukrainian some sentences about agent model for our third course?
My apologies. My Ukrainian is really bad. I mean, I have to visit Lviv to drink something in Kryivka to actually to renew the knowledge. But I will try my best. But may I ask to repeat the question once again?
Please don't forget your language, Ukrainian.
I'll do my best.
Thank you.
If it works better for you, feel free to ask question in Ukrainian. I mean, I understand fine. I just don't use it on daily. That's why English is my main.
Thank you.
I heard that you asked question, but I didn't got it. If you would like me to reply to it, please ask it again in a language you are comfortable with.
Mhm.
Okay. If you would like to know anything later, feel free to contact me. Okay. Yep. Any other questions? Okay, then seems we are done. Thanks a lot for coming. It was a pleasure to talk to you.
Yeah,
And
thanks a lot
if you have
for
any
sharing.
other topics, feel free to reach me.
Yeah, thanks a lot. Hope to see you soon again.
Okay. See you soon. Have a nice day.
Thank you.
Bye bye.